Okay, good evening. I'm Professor David J. De Los Reyes. Okay, it's August 25 already. The time is 12:24 a.m. Okay, my my topic for this morning will be a long video format discussion, and this will still be college algebra. Okay, we are running smooth on college algebra. On college algebra, this will now be lesson number 42. We are running smooth. The topic for this morning will be logarithmic and exponential functions. The relation of logarithmic and exponential function. Okay? Okay, let's proceed. The subject matter for this morning will be college algebra, lesson number 42. The title of the topic will be logarithmic or exponential and logarithmic functions, the relation of the two functions, exponential and logarithmic. Okay, let's try to define what is a logarithm. Logarithm, the simplest form of a definition of logarithm is it is the power to which the base of the logarithm must be raised to equal that number. That's the simplest definition of logarithm. Okay, so I place it here. The power to which the base must be raised to equal that number. If we try to relate that definition on an equation form, it is something like this. The logarithm of x with the base a, and this should be equal to y. Okay? And according to the definition of logarithm, the logarithm of x with the base of a is y. Okay? If we could prove that if we get that base and raise that to y, what will come out should be equal to x. That's the definition of logarithm. You got what I mean? On the left hand side, this is the logarithmic form, and on the right hand side, it is the so-called exponential form. So actually, logarithmic and exponential are related, right? So there will be a problem in algebra that will ask to change from logarithmic to exponential or from exponential to logarithmic. So if you hear the term logarithmic, okay, there's a relation function of it, and that relation is actually exponential relation. Okay, for a logarithmic function, okay, we could take the equivalent exponential form of that one, like in this one here. If we try to read this one, the proper way how to read this one is the logarithm of x with the base of a, meaning the base of the logarithm, and this should be equal to y. The equivalent of this under the so-called exponential form, that is e to the y, is equal to x. Because this one here is actually the definition of the logarithm. The logarithm of a number, okay, if we get the base, then raise that to that number, what will come out should be that number x, okay? So the logarithm of x with the base of a is equal to y, okay? For it to become a logarithm, e to the y should be equal to x. So this is the logarithmic form, and this is the exponential form. And which the value x is the number, a is the base of the logarithm, and y is the logarithm of x. Y is the logarithm of x. Because according to the definition, the logarithm of a number is the power to which the base of the logarithm must be raised to equal that number. If e to the y is equal to x, okay, that y is the logarithm. Okay, that's the definition of logarithm. As simple as that one. You only need to remember this concept here, that the logarithm of x with the base of a is equal to y, okay, if e to the y is equal to x. This is the exponential equivalent. This is the logarithmic equivalent. So there are problems in which sometimes they're asking if there is a given logarithmic, what will be the exponential equivalent of that one? Okay, there are rules to follow here. Many of us, the one they are showing on the short video, okay, they try to cancel out if they are specifying antilog, but in here I will show you how to simplify an antilog. It is something like this. If the base of the logarithm is a, and if I will take that a, I will raise that to the logarithm of x with the base of a, okay? If I will try to simplify this one, okay, this should be equal to x. And the proper way to read this one is the antilog of the logarithm of x. The antilog of the logarithm of any given function is just the given function. Okay? If we get the base, we raise the given logarithm, we read this one, the antilog of the logarithm of x is just equal to x. Or the logarithm, or the antilog of the logarithm of any given function is just the given function x. Okay, that's the proper way to read this one. Okay? The other one, the logarithm with the base of a of any antilog, okay, is just x. So you see the significance. The right hand side here is x, and here the right hand side is also is x. But it was the reverse operation, because on the first one, the antilog of the logarithm, and here the logarithm of the antilog, okay, is just simply equal to x. The second one, this is read as the logarithm of the antilog of x. Okay? Because antilog and logarithm are actually opposite each other. They try to cancel out each other. The antilog of the logarithm of any given function is just the given function, and the logarithm of an antilog of any given function is just the given function. A to the x is actually antilog, right? And if we try to take the logarithm of that, if we try to simplify, it will just be simply x. For the first one, the antilog of the logarithm of x is just simply x. If you could memorize these two concepts here, you will not be lost under the study of the so-called logarithmic and exponential functions. Let's try to bring out an example. Find the logarithm of 100. Logarithm of 100, the base here should be 10. Because under the study of common logarithm, if we then place the base here, it is understood to be 10. Okay, I will just place 10 to be specific, okay? Find the common logarithm of 100. The base is 10. The number in which the logarithm is to be found is 100. So if we try to place the logarithm of 100, the logarithm of 100 with the base of 10, okay? Even without using the calculator, I could bring out the logarithm of 100 with the base of 10. It's actually equal to 2. Why 2? Because according to the definition of a logarithm, if I will take the base, okay, then raise that to the logarithm of the number, what will come out should be the given number, okay? Okay, so because 10 squared is equal to 100. If you can understand this one, you just display 100 here, okay? Take the common logarithm, the answer is 2. Okay, but if you know the definition of logarithm, it is the power to which the base of the logarithm must be raised to equal that number. Okay, that's why the logarithm of 2, okay, or the logarithm of 100 with the base of 10 is 2, because 10 squared is equal to 100. Okay, this could not be 3, because 10 to the third power is 1000. It's only 2 that will give the value to be equal to 100. So even without using the calculator, I could bring out the logarithm of 100 with the base of 10 from the definition of a logarithm. It should be 2. Okay. Next one. Find the antilog of the logarithm of 100. Common logarithm of 100. We will find the antilog of the common logarithm of 100. So the base is 10, x is 100. So antilog, right? Okay, we will just take the base. We are using rule number 1. Then the logarithm of 10 of 100. According to rule number 1, if we try to read this one, the antilog of the common logarithm of 100 is just equal to 100. It is just a given function, x. Okay? If you don't want to trust that one, you display 100 here. Okay? Take the common logarithm. Oh, hold on. 100. Take the common logarithm. The common logarithm of 100 is actually 2, right? 2. If we get the value of this one, it is actually 2. Okay? So if this is 2, 10 squared is 100. So this is correct. Okay? A raised to the logarithm of x with the base of a is just equal to x. Okay? The antilog of the common logarithm of 100 is just 100. As simple as that one. Okay, you got it? Okay, let's try to bring out an exercises of changing from logarithmic to exponential and exponential to logarithmic. Okay, exercises. Change to exponential form, meaning the given forms are logarithmic, right? So the problem is asking what will be the exponential equivalent of this. Okay, this will be the proper solution. The base of the logarithm is 2, right? Okay. So to remove this log here, we will take the antilog, right? And the antilog of the logarithm of 2 is written like this. I will get the base, okay? So I'm following rule number 1. I will get the base. This one is antilog actually. I'm taking the antilog. 2 raised to the logarithm of x with the base of 2 should be equal to. I raise the left hand side 2 to the something. For the right hand side, you do something also. It should be 2 raised to the y, right? What you will do on the left, do it on the right, right? But if we try to simplify the left hand side, what will be the simplification of this? What will be the simplification of this one? Because if we try to read this one, the antilog of the logarithm of any given function is just a given function. So it will just, the simplification of this will just be simply x. So x will be equal to 2 to the y. So the exponential equivalent is actually x is equal to 2 to the y. Okay? These two functions here are actually equal. Okay? This is the so-called logarithmic form, logarithmic. And this is the so-called exponential. Exponential. That's why the problem is asking we change this logarithmic to exponential. That's the way how to change from logarithmic to exponential. You take the antilog of both sides. Okay, example number 2. Am I still on camera? The logarithm of 32 with the base of x is equal to 5. Try to express this one in the so-called exponential form. This is logarithmic. There is a logarithm sign over here, right? The base is x, right? So you always take the base, raise that to the given terms, right? For us to take the antilog. So if the base is x, x raised to the logarithm of the left hand side, the logarithm of 32 with the base of x should be equal to the right hand side, it will be x, okay, raised to the fifth power. What you will do on the left, do it on the right, okay? But the rule to follow is you must have to raise the base, okay? Okay? it's the base. No other number that you will get. It should be the base to take the antilog. So x raised to the logarithm of 32 with the base of x should be equal to x to the 5th. And if we try to simplify this one, what is the simplification of that? The antilog of the logarithm, okay, they try to cancel out each other. The antilog of the logarithm of any given function is just the given function. The given function is 32, right? So the simplification of the left hand side will be 32, and for the right hand side, it will just be simply x to the 5th. So meaning to say, the logarithm of 32 with the base of x equal to 5, in exponential form, the equivalent is 32 is equal to x to the 5th. Okay? So logarithmic and exponential are cousins, you know. They are related. Okay, exercise, other form of exercise, change to logarithmic form. For the first two, we change it to exponential, the given logarithmic. For the last two here, we are given an exponential and we change it to logarithmic. So it will be the reverse operation, right? Okay, example number 1, for this logarithmic form. Y is equal to 4 raised to x plus 1. Oh, this is under logarithmic, right? No, exponential. We got an exponent, right? And the problem is asking what will be the equivalent of this one in terms of logarithmic. Okay? Our base is 4, right? Our exponent is x plus 1. To bring out the logarithmic equivalent, take the logarithm of both sides. Okay? Take the logarithm. The logarithm of y, okay? Our base is 4, right? With the base of 4 should be equal to the logarithm of the right hand side, again with the base of 4, right? And what will be the simplification of the left hand side? You cannot simplify the left hand side as it is. The logarithm of y with the base of 4 is just the logarithm of y with the base of 4. And for the right hand side, what will be this? What will be the simplified equivalent of this? It is rule number 2. The logarithm of an antilog, okay, is just the given function. Because the log and the antilog cancel out each other, so what will just come out for the right hand side will just be simply x plus 1. So the logarithmic equivalent of the given exponential y equal to 4 raised to x plus 1 is the logarithm of y with the base of 4 is equal to x plus 1. Okay? In the simplification of this, I use rule number 2. The logarithm of an antilog is just the given function, right? They try to cancel out each other. On the first one, the antilog of the logarithm is still the given function. Okay? But this one here falls under rule number 2. The logarithm of an antilog. Right? Last one. 5 to the x is equal to 212. This is an exponential equivalent, right? This is an exponential equivalent. The base is 5. Am I still on camera? The base is 5 and the exponent of x. Okay? Okay? Take the logarithm of both sides with the base 5, right? So the logarithm of the left hand side, the logarithm of 5 to the x with the base of 5, I follow this because the base is 5, right? Should be equal to the logarithm of 212, the right hand side is 212 with the base of 5. And what will be the simplification of the left hand side? It's rule number 1. Rule number 2. Right? The logarithm of an antilog. The logarithm of an antilog, because 5 to the x is read as antilog, right? So the logarithm of antilog of 5 to the x is just simply x. So the left hand side can be simplified into x. And for the right hand side, okay, we cannot do anything about the logarithm of 212. It's just simply the logarithm of 212 with the base of 5. So meaning to say, 5 to the x equal to 212 under exponential, And under logarithmic, the equivalent is x is equal to the logarithm of 212 with the base of 5. Okay? Okay, that's it, guys. That's the first two topics under the study of logarithmic and exponential functions. At least we now know what is the logarithm of a function. Okay? We know how to take the antilog. Okay? And there are two operations in taking the antilog. That is, the antilog of the logarithm of any given function is just the given function, and the logarithm of an antilog is just the given function. Because without knowing rule number 2 and number 1, you cannot perform this operation here. Before we will go with the problems involving laws of exponents, okay, we should know this one, okay. So for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDBJ_de_los_Reyes. If you want to share it, please click share. This is exponential and logarithmic, or logarithmic exponential. Just follow these two rules here, and you will not be lost under the study of algebra. Okay, good morning from Los Angeles. Professor de los Reyes.